Hello everyone, in this video let us learn some model questions on Charles law. So, these type of questions they may ask in exams. Okay, here we have one question. See, which of the following is correct curve for Charles law when the curve is plotted at 0.821 atmosphere for 10 mole ideal gas. Okay. So, these are the curves plotted at 0.821 atmosphere for 10 mole ideal gas. Okay. So, first of all we must see here ideal gas equation PV equal to nRT, PV equal to nRT. Here pressure how much they gave 0.821 and the number of moles 10 moles. So, I am just substituting here 0.821 into V is equal to number of moles 10 and R value I am taking here 0.0821 into temperature. Okay. So, here V by T is equal to 10 into 0.0821 by 0.821. Here R value I am taking 0.0821 in liter atmosphere per Kelvin per mole I am taking here. Okay. So, finally, if you cancel this all, then V by T equal to 1. Okay. Is this clear all of you? Then we have to check these graphs. Here if you see in option A, V by T versus V. Okay. So, here the straight line from origin, but this is absolutely wrong because V by T versus V is always constant curve. At constant pressure and number of moles, the V by T value never change, that is always constant. So, even if you change the volume or the temperature, this curve never changes, right? It is always constant. Okay, na? So, you can neglect this option. Okay, option A neglect. Now, come to option B. Here V versus T, okay, the curve is correct, this is from origin, but see here V by T is equal to 1 from this given data. V by T is equal to 1, V equal to T. So, this is in the form of y equal to mx, there is no intercept, no. So, y equal to mx. So, m must be here, slope must be 1, slope must be 1, but here the slope tan 30 how much? Will calculate the slope tan 30, no, tan 30 how much? 1 by root 3, but what is the slope here? Actually 1. So, you can neglect this option. Okay. First one you have neglected, then the second one also this plot is not at the conditions given. And see here option C, log V versus log T. Okay. So, we have one relation log V minus log T is equal to constant, log V minus log T equal to constant. Suppose if log V increases, then log T must be increased to make it constant. Okay. But here the curve is not like that, actual curve is log V log T, this curve should be like this. Okay. I explained about these curves in video, Charles law video. So, you can refer to that, video is available in the channel. So, this plot also neglected, wrong, these three are wrong at given conditions. And see option D, let us see here V by T equal to 1 from this given data, V by T equal to 1. So, on both side I am multiplying with V. So, V square by T equal to V, V square by T equal to V. So, this is in the form of y equal to mx. So, the slope must be here 1, right, the slope equal to 1. So, tan 45 how much? Tan 45 degree, that is 1. So, this option is correct. Okay. So, this is the exact graph plotted at given conditions. Okay. Right. Now, see here one question is there. Cooking pots have loose fitting lids to allow air to escape while food being heated. Generally, while cooking, generally that cooking pots will have a loose fitting lids, very loose lids. Why? Because to allow air to escape, the air present inside the container, it has to escape out while heating to reduce the pressure inside the container. So, cooking pots have loose fitting lids to allow air to escape while food being heated. Okay. So, here I am taking 3 liters capacity one cooking container, 3 liter capacity is heated from what? 22 degree centigrade to 100 degree centigrade. Okay. Now, what is the percentage of volume increased at constant pressure? Constant pressure. Okay, at constant pressure, V is directly proportional to T, right? So, V1 by T1 equal to V2 by T2. Okay, what is the initial volume here? V1. Initial volume, we have to take the container volume. What is the container volume here? Container means cooking container. What is the container volume here? 3 liters. Okay. And the final volume, first we have to find what is the T1 temperature given 22 degree centigrade. 22 degree centigrade means convert into kelvins, it is 295 Kelvin. Always we must take in kelvins, capital T, no. And T2 from which temperature to which temperature? Here 22 degree centigrade to 100 degree centigrade. So, this is this also convert to Kelvin scale, that is 373 Kelvin. Okay. So, substitute these values here. V1 3 by T1 how much? 295 is equal to V2 we need to find here, and T2 373. Okay. So, from this V2 equal to 3 into 373 by 295. Okay. So, on solving this you will get here 3.8 liters, the V2, the final volume. On solving this, on simplification of this one, you will get here 3.8 liters. Okay. But the question is not final volume, what is the percentage of volume increased at constant pressure? Percentage of volume. Okay. So, how much volume increased? Volume increased equal to final volume minus initial volume. Okay. So, final volume 3.8 minus initial volume how much here? 3 liters. How much increased? 0.8 liters increased. So, this 0.8 liters how much percentage in the initial volume? Okay. So, here percentage of volume increased equal to how much volume increased here? 0.8 by what is the initial volume? 3 into 100. Okay. So, on solving this you will get here the percentage of gas how much increased? 26.4, approximately 26.4 percentage increased, this much volume increased. Okay. Now, is this clear, this problem? Okay. Now, let us see one more problem on this, on Charles law. Okay, we have one more question on Charles law. See here, an open empty plastic container, its volume 2.05 liters. It's an empty plastic container having 2.05 liters. It is kept in a refrigerator at 5 degrees centigrade. That empty container kept in refrigerator, and the temperature maintaining inside the refrigerator is 5 degrees centigrade. Okay. And is now allowed to warm up to 21 degrees centigrade, means from the refrigerator that box was taken out and kept at room temperature, that is 21 degrees centigrade. What happens? The temperature increases, no? Okay, whatever the gas or air present in that container will expand. On a kitchen counter, okay, up to 21 degrees centigrade on a kitchen counter, calculate the volume of air that will escape the container. What is the volume of the air will escape from that container? So initially that empty container kept into the refrigerator, and inside the refrigerator the temperature maintained at 5 degrees centigrade. Okay, so shall I take here T1 how much? 5 degrees centigrade. 5 degrees centigrade means what? Convert into Kelvin plus 273, so 278 Kelvin, and it is allowed to warm when the container was taken out and kept at what temperature in kitchen? 21 degrees centigrade. So T2 how much? 21 degrees centigrade. 21 degrees centigrade also we have to convert into Kelvin scale, that is 294 Kelvin. So what is the volume? What is the volume of container? Actually 2.05 liters. So final volume how much? Let us find here final volume. So V1 by T1 is equal to V2 by T2. Okay, V1 how much? 2.05 liters. T1 how much? 278 Kelvin is equal to V2 how much? V2 we have to find here, T2 294. Okay, so V2 equal to 2.05 into 294 by 278. Okay, on solving this, on simplification of this one, you will get here V2 2.17 liters. What is the initial volume? Initial volume 2.05 and the final volume 2.17 liters. So how much gas escaped from that container? So air escaped from container is equal to final volume V2 minus initial volume V1. 2.17 minus 2.05. So here 0.12 liters of volume escaped out. Okay, like this very simple questions are there on the Charles law. Okay, thanks for watching.